This video is provided by Coaching Online iit-jee and delivered by Praveen Kumar and the NEET. This is free tutorial videos which helps iit-jee and medical entrance exam aspirant in secure a rank. In all the lecture series we will solve previous year's question of iit-jee and medical entrance exam. We will solve physics, chemistry and mathematics question and explain all the fact related to problems in great depth, and an cutting-edge analysis is provided. Our team upload one video per day. So to get daily update, subscribe our channel. Special thank you to my dad Shri Amrendra Kumar Pandey, G, and my mom Shri Mt Neelam Pandey, G. I dedicate this videos to my younger sister Miss Pratima Pandey. Thank you for tolerating me during making the videos. Without you this is not possible. Thank you.
Okay, welcome to free online coaching. This is Praveen, and in this lecture we will solve a problem of thermodynamics which has come in 1989, and it is a 8 marks question. It is a big question. Okay, and this is for this lecture is for revision purpose. And when I say we are doing revision, it means that we forget almost all the formulas. It is necessary. Okay guys, and and there are two ways for you. First, you should read this theory, you should read the theory and memorize all the formula. Memorize. And second thing is, whatever memory you had, whatever memories you had, use it and solve the question. And when I say thermodynamics, then something which cannot be forget. For example, first law of thermodynamics. Nobody can forget first law of thermodynamics. What is the first law of thermodynamics? dq is equal to dw plus dE. Nobody can forget this law. Nobody can forget that this equation PV is equal to nRT for ideal gas. Nobody can forget about this. Okay, so this we try to solve all the questions with the help of only these three. Okay, and something which is called energy is equal to E is equal to 1 by 2 FKT. Okay, FKT, and something relation over okay. This is for the one molecule, and I will replace it with R when we talk about 1 mole. Okay, here F is the degree of freedom. You cannot forget all these things. Okay, so we just try to solve the question with the help of this basic equation. Okay, and we'll solve all the question. There is no need to memorize. Okay, so I will follow this step because it is my favorite step. Okay, we have because we human beings are not hard disks. Okay, a lot of data we cannot store data. We analyze the things with our experience. Okay, so as being a human being, I am just going to solve the question with a tiny memory. I am not going to deal of a lot of theories and formulas and whatever present in thermodynamics. Okay, so if you know the first law, and if you know the PV is equal to nRT, and something like energy etc. Energy etc is not always necessary, and if you know it, then it is good, otherwise it is too good. Okay, so guys, okay, so what is the question is that question in this question there is a cylinder. In this cylinder, this is a cylinder, and here is heater. Okay, here is this is, and this is attached to a spring. Okay, spring. Okay, and what happened? You heat the cylinder. Heat is cylinder provide power. Due to it, this gas become heated, and due to heated, it starts slowly sliding. Okay, slowly sliding means at every step there is equilibrium. This this is the massless. This is massless. Then there is equilibrium. Okay, this piston is massless. So there is equilibrium. There is equilibrium between. Okay. There is equilibrium between and pressure and force from equilibrium. When I say equilibrium, that means force due to gases. This is P of gas into area should be equal to. Okay. So there is pressure. This is down. This is pressure by gas. Okay. And this is the atmospheric pressure. P atmospheric into area, and here there is a force by spring. Okay, kx. So guys, it always balance. It always balance. Okay, it always balance. So yeah, it is correct. It always balance. Okay, and it is always in equilibrium. This piston is in always equilibrium. Piston is in always equilibrium. Okay, equilibrium. This piston is in always equilibrium. This piston is in always equilibrium. This piston. Okay. Okay. So the first question, what is the first question? It has asked that due to heat, this has moved. This has moved 0.1 meter. Okay, due to heat, this has moved 0.1 meter, and what is the given is that the spring constant K is equal to 8,000 Newton per meter. Okay, K, this is the spring constant, and here initial pressure, since initially spring is in natural natural state. Okay, natural length. Spring is in natural length. Okay, initially spring is in natural length. Okay, and on P atmospheric is equal to atmospheric pressure is 10 to the power 5 Newton per meter square. Okay, this is called Pascal unit. So 10 to the power 5 Pascal. Okay, and initial temperature is 300 Kelvin, and initial temperature is 300 Kelvin. After that, area, this cross section area is nearly, okay, this area is 8 into 10 to the power minus 3 meter square. Okay, this area is 8 into 10 to the power minus 3 meter square, and this initial volume, okay, this initial volume is V1 is 22.4 into 10 to the power minus 3 meter cube. Okay guys, and due to heat, this piston has moved 1 meter in this toward left. Okay, this piston has moved 0.1 meter toward left, and what we have to find final temperature first thing, and second thing first thing is find final temperature, and second thing is find heat supplied. Okay, heat supply by this heater. Okay, this how much heat will supply by this heater. Okay, so it is the very simple question, and we are going to solve it. Okay, and this is the very important, the thinking about this equilibrium is very important. Okay guys, this thinking about this equilibrium is very important. Okay, guys, since there is this is always in equilibrium, initially this is in rest. Okay, so its kinetic energy is 0, and its final kinetic energy will be 0 because it is in equilibrium. Okay, because this is in equilibrium, the final kinetic energy will be 0, and final kinetic energy is 0. Final kinetic energy is equal to 0 because it is in equilibrium. Yeah, Initially it is in rest, final kinetic energy will be 0. Final kinetic energy will be 0. So the change in kinetic energy will also 0. Okay, change in kinetic energy is also 0. So work done should be 0. Okay, this is the work done should be 0. It is very simple, you could calculate it. Work done will be 0. So what is the work done? What is the work done? Work done on piston. Work done by piston. Work done on piston. Work done on piston. Okay, who work done on piston? Who do work on piston? Gas will do work on piston. Okay, this spring spring will do work on piston, and atmosphere do work on piston. Okay, who will do work on piston? Gas will do work on piston, spring will do work on piston, and atmosphere will do work on piston. Okay, so look here, this is the direction of motion, this is the direction of displacement. Okay, in this direction displacement take place. And what is the direction of force? A force by gas is this. So work done by gas will be positive. Work done by gas positive. Work done by gas. Okay, gas will be positive. Work done by gas will be positive. And spring, what is the force by spring? Spring, this is the force by spring. Okay, and so this will be negative because movement is in this direction. And spring negative. Okay, spring, work done by spring is negative. And again, what is the work done by atmosphere? Work done, again, look at the force. This is the pressure by atmosphere. So what is the work done by it? Negative, because this is the direction of displacement. Atmosphere will negative. Okay, so just find it. Okay guys, so what is the work done by spring? Work done by spring is half minus half 8000 into k. This is x, displacement is here, displacement is 0.1 meter, so into 0.1 meter square, 0.1 square, plus minus, here minus because we are going to work done by atmosphere. And what is the atmospheric pressure? Atmospheric pressure is 10 to the power 5 Pascal. Atmospheric pressure is 10 to the power, atm is 10 to the power 5 Pascal. And this remain constant because this is the atmospheric pressure. It remain constant. Slight movement in this will not going to change it. Okay, so it remain constant. And so what will be force by it? The force by it will be atmospheric. What is the pressure? Force upon area. I know pressure, I know area, then I find a force. So what is the force? Force will be pressure into this cross section area, because on this cross section area this force, this pressure is going to apply. So minus 10 to the power 5 into my cross section area is 0.8 into 10 to the power minus 3. Okay, 8 into 10 to the power minus 3 plus work done by gas, which is positive, work done by gas. This should be equal to change in kinetic energy. This should be equal to 0. So what is the work done by gas? Work done by gas. Work done by gas should be equal to, this will become, listen, this become 4000, and this become 10 to the power minus 2. This become 40. Okay, 40 plus, and if you look it carefully, if you look at it very carefully, it become 8. Okay, 40 plus 80. 40 plus 80, actually 10 to the power minus 4. It is 8. Yeah. Okay, 3. 800. It should be 800. 40 plus 800. Okay, this will become 40 plus 800. It not should be 80. This should be 40. 10 to the power minus 3. Yeah, this become 800. Okay, so what it become 840. Okay guys, this become 840. Okay, actually you should check it, you should check it. It is 10 to the power minus 3 or 10 to the power 4. Okay, 10 to the power minus 3 or 10 to the power 4. You should check it. Okay, so it will become 8 into 40, because according to this should be 800 and 8040. Okay, so work done by gas is equal to 8040. Okay, 840, not 8040, 840. Okay guys, okay, now we have find what is the work done by gas. Okay, so now, guys, we know PV is equal to nRT. PV is equal to nRT. Okay, PV is equal to nRT. And what is the P initial? Oh, this is the PV is equal to nRT. Number of mole is always constant. R is constant, so T. And okay, so P initial is 10 to the power 5 into this. This is 2.4 into 10 to the power minus 3. This is equal to nR, and T is equal to 300 Kelvin. Okay, this T is, it is given that initial temperature is 300 Kelvin, so T is 300 Kelvin. Again, now and final. Okay, we have to find final pressure. So final pressure I can calculate it by this. Oh, this, since this is in equilibrium, what can I write? P into A. This should be equal to P naught into A plus K x. Okay, if you look at it very carefully, this become P is equal to P naught plus K x by A. And what is the P naught? 10 to the power 5, and plus this K 8000. Okay, 8000 plus, and this become 10 to the power 0.1 10 to the power minus 1 divided by 8 into 10 to the power minus 3. Okay guys, so if you look this very carefully, what you get? 10 to the power 5 plus 10 to the power 5. Okay, so 2 into 10 to the power 5. The final pressure is 2 into 10 to the power 5. And again, what is the new volume? If this has reached here, what should be the new volume? If you look at very carefully, this area is 8 into 10 to the power minus 3 meter, and this is 0.21. So what is the new volume? New volume will be 2.4 into 10 to the power minus 3 plus 0.8 into 10 to the power minus 3, because initial volume is 2.4. Okay, it is given in the question. So what will be total? 3.2 into 10 to the power minus 3. 3.2 into 10 to the power minus 3. Okay, so it is very simple to find. Okay, so I had find what is the pressure, final pressure, what is the final volume. So I can calculate it very easily. 2 into 10 to the power 5 plus 3.2 into 10 to the power minus 3. This should be equal to nR. I don't know what is the temperature. Let's divide this. Okay, if I divide it, what I get? 2 into 3.2 divided by 2.4 is equal to T divided by 100. Okay guys, so what you get? So what you get from here? That this, if you look at very carefully, this 4 by 3 into 300, and this will become 800. Okay, what is the temperature? 800 Kelvin. Temperature is 800 Kelvin. Okay guys, so temperature is 800 Kelvin. Okay, you got this? Now we will find the temperature is 800 Kelvin. Temperature is 800 Kelvin. Okay, so temperature is 800 Kelvin. And now guys, we know what is the work done. Work done by gas is equal to 840 joule. Work done by gas is 840 joule, and everything is okay, 840 joule. And now, okay, what is the dq? Dq is equal to plus de plus de plus and dw. Okay, my gas is ideal gas. It is given in question. Gas is ideal gas. Gas is ideal gas, and it is monoatomic. Okay, it is monoatomic. What is monoatomic? It means it has 3 degree of freedom. Okay, degree of freedom is 3. Degree of freedom is 3. So you know what is the change in energy? Change in energy will be 3 by 2 and R, and this is T2 minus T1, and this into N. Okay, so 3 by 2 into R. If you look at here very carefully, I can write P2 V2 minus P1 V1. Okay guys, so what it become? 3 by 2 10 to the power into, okay, look, P2 2 into 10 to the power 5 into 3.2 into 10 to the power minus 3 minus 10 to the power 5 into 2.4 into 10 to the power minus 3. Okay, if you see it very carefully, what I get, 3 by 2 6.4 minus 2.4, okay, into 6.4 minus 2.4, it is correct? Yeah, into 10 to the power 2. Okay guys, it is correct? Yeah. So this is 3 into 2 into, look, this is carefully, it will become 4 into 100. Okay, I got this, it will become 600. Okay, 600 plus 84 840, it will become 140. Okay, you know guys, in my question, in the question book in which I had, see, it is a Aryan book. Okay, but in Aryan book I think this has calculated somehow 80. I don't know, it is this, since it is his mistake. Yes, somewhere there is mistake in data. So it has calculated somehow 80. It will not come 80. You should check it here. It is either should be 80 or 800. Okay, you should check it here. If it will 80, then it will become 120. Okay, 120 plus 600, that will become 720. Otherwise it is correct. Okay, if that had, okay. See you guys in next lecture. You know guys, when I am calculating work done by atmosphere, I had calculated a mistake. I had not calculated this. Okay, 0.1. What I had done 10 to the power 5 into 8 into 10 to the power minus 3. You know, I had that is for it 800. I had not think about, I had just forget it. Okay, so it will become 80. Okay, it will become 80, and 80 plus 40, it will become 120. Okay guys, actually I had just, by mistake, I had not see it when I solving the question. Okay, so work done by atmosphere will be 80, not 800, because if I take, actually I had not seen 0.1, I had done somehow 1, so you should check it. Okay, this will become 120, and okay, and this 40 is by spring, so 80 plus 40 is equal to 120. Okay guys, and 600 plus 120, this should be the 720 joule, and this amount of it will be supplied by this heater. Okay, so we had calculated final temperature and what is the work. This question has this is the 8 mark question. It has come in 1989. Okay, so at that time, if somebody had solved it, then I'm sure that he had selected in iit-jee. Okay guys.
Hey buddy, hope you understand whatever I am explaining to you. So work hard and enjoy the life. If you want to see me tomorrow, then subscribe my channel, because viewers like you support and motivate us to make videos. Please share this by clicking on the share button on Facebook, Twitter, Instagram, and other social networking sites, so that a needy one get benefit and spread about it among your friends. My dear students, an important message for all of you. We are trying to take an online exam. which will be totally free for trial period means till July 2017. If you are interested in it, then you can register by sending an email or a message on WhatsApp. My WhatsApp number is 700-771-9110, or by giving them a call on 7-755-896-205. We will give more detail about it in our forthcoming videos. Thank you so much.